In this video, we are going to talk about decomposition of a function. So, decomposition of a function is simply breaking down the function into smaller parts or smaller compositions. Okay? So, before we solve this example on the screen, I'd like you to know something. If you are looking at decomposition of a function, anytime you have x and an operation, an arithmetic operation is performed on x, you can assign that as a function. So if you have x minus 4, 6, if you have x minus 4, this is an arithmetic operation on x. So you can take this as a function. If you have 6x, this is an operation that's performed on x. So you can take this as a function. If you have x cubed, this is an operation performed on x. So you can take this as a function. So basically, anytime you manipulate x, okay, or perform an arithmetic operation on x, you can take that as a function. So with our newfound knowledge, let's try to decompose this function into smaller parts. So let's say this is f of x equals to 6x minus 4. So 6x, 6 performs an operation on x. So this can be seen as a function, okay? So we can say a of x is equal to 6x. Because we've said a of x equals to 6x, we will replace 6x with x. Okay? So we now have f of x is equal to x minus 4. Okay? So because minus 4 does an operation on x directly, we can say this is also a function. Okay, so we can say b of x is equal to x minus 4. Okay, so from here now, we can now say f of x. Now we've broken our function into smaller parts. Is equal to b of a of x. Okay, or you can write it like this by saying b of a of x. Okay, so you are saying b composed of a of x. So let's pick another example for you to understand better. So for a second example, say we have f of x is equal to open bracket x plus 5 by the power of 4. Okay, so if you're asked to decompose this into component functions, the first step is to look at what is inside the bracket. An operation is being performed on x here. So x plus 5 is a function. So I'll be saying a of x. Okay, let a of x equal to x plus 5. So we are going to replace x plus 5 with x. So the new function will look like f of x is equal to x to the power of 4. Okay, so x to the power of 4 is an operation performed on x. Okay, so this means that we can replace x to the power of 4. We can say x to the power of 4 is a function. So we can now say b of x is equal to x to the power of 4. Okay, so to represent f of x in its component forms, we could say f of x is equal to b composed of a of x. Okay, so you can view the composition backwards. So we are starting from b to a. If we had c, it would be from c to b to a. So let's take another example again. So let's say f of x is equal to 3 open brackets 2x plus 7 to the power of 4. Although this is a bit complicated, I want you to pause the video and try this one yourself. Okay, so like we've been doing before, we start with where the x value is. So we are looking at 2x here. So 2x is an operation on x. Okay, so we can say let a of x is equal to 2x. So we are going to replace 2x with x here. So f of x will become 3 open bracket x plus 7 to the power of 4. So at this point, the next operation on x is x plus 7. So we are going to be saying, okay, let b of x is equal to x plus 7. Okay, so we are going to be replacing x plus 7 with x raised to the power of 4. We are going to be replacing x plus 7 with x. So this would be f of x is equal to 3 open bracket x to the power of 4. Okay, so next step, the next operation performed on x is x to the power of 4. So we are going to be saying, okay, let c of x is equal to x to the power of 4. So we are going to be replacing x to the power of 4 with x. So f of x is so f of x is equal to 3x. So the next operation performed on x is 3 times x. So the last function is d of x, which is equal to 3x. So to represent f of x in its component form, we can say f of x is d composed of c composed of b composed of a of x. Okay, so that's how to solve decomposition of a function problems. Now if you like the video, leave a thumbs up, share with your friends, and subscribe to the channel. Thanks for watching again.
Be right.